This is mathheals.com, where you can find more links to math YouTube videos if you wish. Let's take a look at rotation of axis, general form of a conic. Now, to identify a conic, except for degenerate cases, we got in our general form ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Now we're seeing all the different standard forms for parabola, ellipse, and hyperbola. This is a general form. And depending upon what numbers are in front of these, helps define what the shape is. Like it's a parabola if b squared minus 4ac is equal to 0. It's an ellipse or a circle if b squared minus 4ac is less than 0. And it's a hyperbola if b squared minus 4ac is greater than 0. Let's look at our first problem. And we got y squared plus 6y plus x minus 7 equal to 0. And it says identify the graph of each equation without completing a square. Well, let's see. Now the three things we need, by the way, are a, b, and c. Now the a is what numbers before x squared. We don't have an x squared. So a is going to be 0. B is numbers before our xy. We don't have an xy, so it's 0. And c is numbers before our y squared. Well, the number for our y squared is the invisible 1. Well, we need to find b squared minus 4ac. All these revolve around that. So b squared minus 4ac. So we got 0 squared minus 4 times a, which is 0, times c, which is 1. 0 squared is 0. 4 times 0 times 1 is 0. 0 minus 0 is 0. So if it's equal to 0, then it's our first one here defines a parabola. So that's a parabola. Sometimes it may be nice to know what you're dealing with before you dive into the problem. Are you looking at a parabola, ellipse, what exactly? Okay, let's look at this one. We got 4x squared plus y squared minus 16x plus 6y plus 3 equals 0. Okay. Come back here, we need a, b, and c. A is what's before x squared, which is 4. B is what's before xy, which is 0. And c is what's before our y squared, that's right here, which in this case is 1. So b squared minus 4ac. So we got 0 squared minus 4 times a, which is 4, times c, which is 1. 0 squared drops away. 4 times 4 times 1 is 16, so we got negative 16, which is less than 0, which means it's an ellipse, or a circle. Specifically, it's an ellipse. The numbers would have to be the same in front of the squared part. See how this is a 4x squared? This would have to be a 4y squared for it to be a circle. Look at our third problem here. We got x squared plus 16xy plus y squared minus 5 equal to 0. Okay, a is what's before x squared, which is 1. B is what's before our xy, which is 16. And c is our number for our y squared, which is 1. I'm just looking at what's before the x squared, what's before the xy, what's before the y squared. Well, then we want to find b squared minus 4ac. So we'll have 16 squared minus 4 times a times c. I have no clue what this one is, but it's greater than 0. But let me see. 16 squared, 256. So we've got 256 minus 4, and that gives us 252. which again is greater than 0, so it's a hyperbola. Now we're going to be taking some equations in general form that have an x and y component and eliminating the xy component by doing rotation of axis. And that's what these formulas revolve around. Given the equation ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, then we'll figure out our angle of rotation, where cotangent 2 theta is equal to a minus c over b. Then using that, we can come up with the following substitution. X is equal to x prime cosine theta minus y prime sine theta, and y is equal to x prime sine theta plus y prime cosine theta. You may have to use these formulas. Cosine theta is equal to square root of 1 plus cosine 2 theta over 2, and sine theta is equal to square root of 1 minus cosine 2 theta over 2. Those are variations of the double angle for cosine, in case you're wondering. Now I'm not going to really go over this. I put this in this PowerPoint so you'd have it. Standard form of parabola, ellipse, hyperbola. I think every one of the problems I'm working is a hyperbola. Didn't really mean to do it that way, but that's the way it came out. Well, let's look at our first problem here. Actually, let me save this, because we'll need the room. And let's see. Trig rotation of axes. Page 01.pdf. It says rotate the axis so that the new equation contains no xy term. Analyze and graph the new equation. Okay, so we got xy is equal to 4. Well, let's come up to our rotation formulas. Now, given it in this form, and you're saying, well, that doesn't look like that form. Well, you're missing a lot of these. A lot of these are zeros. Doesn't really matter. What we're needing for our formula here is we need a, b, and c. Well, remember a is the numbers before x squared. That's the same as before, which is 0. B is a number that's before xy, which is the invisible 1 in this problem. And c's are a number for our y squared, which is 0. Technically, I'd want that 4 over on that side to be in general form, because it has to have 0 on this side. But since I'm not using the constant term, which is the f, then I don't really care. Okay, first thing we want to do is figure our angle of rotation. So we've got cotangent 2 theta is equal to a minus c over b. Yeah, let me open my window here. Wife's got the heat up. I think she's sick. Killing me. Okay. So we've got cotangent 2 theta is equal to a, which is 0, minus c, which is 0, over b, which is 1. So I've got cotangent 2 theta is equal to 0 minus 0 is 0, 0 divided by 1 is 0. Now remember from our unit circle, cotangent is x over y. So I'm thinking, okay, where's cotangent equal to 0 at? Well, cotangent is equal to 0 when x is 0. Because if this is 0, 0 over something gives you 0. Well, x is equal to 0 at 90 degrees. So cotangent of 90 degrees is equal to 0. Well, we're then going to set this 2 theta here equal to the 90. And you get 2 theta is equal to 90 degrees, or theta is equal to 45 degrees. So that's going to be our angle of rotation. It's kind of hard to work this particular one when you have 0 like that any other way. Now, I'm going to show a problem later on where there's another way you can find that angle. But if we try to rewrite this in terms of tangent to theta, I'd have 1 over 0, and then there's no way I could plug in my calculator. Okay, so now we have our angle of rotation, 45 degrees. That's the first part here. Well, then these are going to be our substitutions. So we'll come up with our substitutions. X is going to equal to x prime cosine theta minus y prime sine theta. And y is going to equal to x prime sine theta plus y prime cosine theta. Well, we just said theta is 45 degrees, so this is going to be x is equal to x prime cosine of 45 degrees minus y prime sine of 45 degrees. And y is going to be equal to x prime sine of 45 degrees plus y prime cosine of 45 degrees. Well, cosine of 45 degrees is square root of 2 over 2, so this gives us square root of 2 over 2 x prime minus sine 45 degrees is square root of 2 over 2 y prime. And then y is going to equal to square root of 2 over 2 x prime, so that's sine 45. And then cosine 45 is also square root of 2 over 2 y prime. Now, you're probably better off if they have a fraction in common like this to factor it out. So I'm going to factor out a square root of 2 over 2, and that gives me x prime minus y prime. And here I'll factor out a square root of 2 over 2, and that gives me x prime plus y prime. Now all these primes are going to drive you nuts. So we're going to let p equal to x prime and q is equal to y prime. We'll plug those back in later on. So our substitutions are going to be square root of 2 over 2 p minus q. Try to write a little bit better there. And y is going to equal to square root of 2 over 2 and p plus q. Okay, now we're ready to do our substitution. So we got xy is equal to 4. That's our initial problem. And we just came up with what x and y is equal to. So I say x is equal to this, so I'll go ahead and plug that in for x. So I got square root of 2 over 2 p minus q times y, which is square root of 2 over 2 p plus q equals 4. Well, square root of 2 over 2 times square root of 2 over 2, square root of 2 times square root of 2 is 2. 2 times 2 is 4. P minus q times p plus q. These are conjugates. All we have to do is multiply our first parts together and our last parts. So we got p times p is p squared minus q times q is q squared. If you don't see that, it's no big deal. If you go through and do all the algebra, you'll see the middle terms drop away. Well, this is 1/2 p squared minus q squared equals 4. And I'm going to go ahead and multiply that 1/2 through. So I got 1/2 p squared minus 1/2 q squared equals 4. And I want a 1 on this side. Because if you look at this form, this is hyperbola. Remember, you got something squared minus something else squared equal that. You want to get a 1 over here. So multiply everything by 1/4. So we got 1/4 times 1/2 p squared minus 1/4 times 1/2 q squared equals 1/4 times 4. So that gives us 1/8 p squared minus 1/8 q squared is equal to 1. Which gives us p squared over 8 minus q squared over 8 equals 1. Now, remember our substitution. We said p is equal to x prime, and we said q is equal to y prime. So we're going to plug those back in. So we're going to have x prime squared over 8 minus y prime squared over 8 equals 1. Now, I'm going to go to another page and continue this problem. I won't finish the problem on all of these because some of them are so nasty because I made the numbers up that you can't really actually do it by hand. So let me save this. Okay, so let's continue this problem. I think we're on problem number 4. Yeah, problem number 4. Okay, we said it's a hyperbola. So let me come down here to my form. Let me write down what I have left. I said this was x prime squared over 8 minus y prime squared over 8 equals 1. Okay, well, before the minus, we have x squared. So before the minus, x squared is 1 on the left. Well, we want to write strictly in standard form, which means the top part needs to be x plus or minus a number. Well, this will be x prime minus 0 squared. Remember, you can always do a minus 0. This 8, I can put a square root around it and write it that way, because we want to write that as something squared. Go watch the lesson on hyperbolas if this is totally confusing to you. This will be y prime minus 0 squared, and then this will be the square root of 8 squared equals 1. So this will be x prime minus 0 squared. This simplifies a little bit. 2 square root of 2 squared minus y prime minus 0 squared over 2 square root of 2 squared. Okay, so working with the formula on the left. Our h is this right here, and it would be opposite sign, but 0 doesn't have a sign. This is our k, and it would be opposite sign, but 0 doesn't have a sign, so it's a 0. The number under our x squared is an a, so a is 2 square root of 2, and this would be our b, 2 square root of 2. Well, we need our c. So come over here. Our c, we use this formula. So we got b squared is equal to c squared minus a squared. So and you can put in b of 2 square root of 2, but square root of 8 might actually be a little easier. If I put that in, and then c squared minus, and a was also square root of 8. So that gives me 8 is equal to c squared minus 8. Take that over, we get 16. So c is equal to square root of 16, or c is equal to 4. Okay, so now we have our 5 values. So we got a is equal to 2 square root of 2. We'll probably want to get a decimal version of that, so let me go to my calculator here. 2.8. Okay. And b will be 2 square root of 2, which is approximately 2.8. c is 4. H is 0, and k is 0. Now it's asking us to, in the instructions, to analyze and graph the new equation. I'm going to analyze the equation, find all the different pieces. I may not graph it depending upon how hideous they come out, so we'll see. Okay, what are we working with? Formula on the left. Okay. So formula on the left, center is HK. So center is HK, which would be 0, 0. That's right there. Okay. And then our transverse axis is parallel to the x-axis. So transverse axis is parallel to the x-axis. Okay, well here's the x-axis. Parallel would be that. That'd be the form y is equal to number. And it'll be the y part of our center. So we'd have y is equal to 0. Vertices, or foci, even though we're not going to use them. Foci is h plus ck and h minus ck. So we got h plus ck and h minus ck. Well, h is 0, k is 0. So 0 plus 4, 0, and 0 minus 4, 0. So our foci will be 4, 0, and negative 4, 0. And then our vertices. Vertices are h plus ak and h minus ak. So h plus ak and h minus ak. Well, h is 0. A was 2 square root of 2. K is 0. So we got 0 minus 2 square root of 2 here. 0. So we're going to have 2 square root of 2, 0, and negative 2 square root of 2, 0. That's almost meaningless. Remember what I said that equaled? 2.8. So we're going to have 2.80, and we'll have negative 2.80. Okay, so 1, 2, 3, so 2.80, about right there. This is my center, and these are my vertices, and negative 2.8. 2. And this is my transverse axis, the y equals 0. So I know what my graph's going to look like that. Okay, our asymptotes. And we got y minus k is equal to plus or minus b over a x minus h. Okay, so we got y minus 0 equals plus or minus b. What was b? B was 2 square root of 2. And a is 2 square root of 2. And x minus h, which is 0. This gives me 1. So this comes out really nice that way. It gives us y is equal to plus or minus x. So our asymptotes will have y is equal to x, and we'll have y is equal to negative x. So if I come up here for our asymptotes, we'll have this right here. And our graph, if I were to graph this, of course I'd have to plot points to get a little bit more precision. I'm not going to go to that kind of effort. Our graph would look like this. Okay, now that's not what our original graph looks like. I don't even have our original graph up here. That was this here right here. xy is equal to 4. But if we take this and we rotate it 45 degrees. So if I rotate that 45 degrees, that'll give us our graph of this. Okay. Well, I'm going to use a graphing utility to show this. First off, let's take a look at this one right here. So what I'm going to graph is this right here. Now this is a program called WinPlot, and I'll put a link to it on my website, Math Heals. Also, if you just go to Google and type in Peanut software, you'll find it. I'll come here and I'll choose Window and I'll choose 2-dimension. And I want to choose File, or Equation, sorry, Equation, and choose Implicit, number 3. And we had x squared over 8. So I'm not very good with this. I'm going to do x times x divided by 8 plus, was it plus or minus? Minus. Okay, I lie. Minus y times y divided by 8 equals 1, was it? 1. Okay, we got that right there. Well, we take that, and I'm not very good at drawing these myself. I'm not the perfect person. This package shows it really nice. If I choose down here and choose 1 and choose rotate, and remember 45 degrees is pi over 4. So if I do pi divided by 4 and click rotate, that right there is the graph of xy equals 4. xy is equal to 4. Now, what the rotation of axis allows us to do, it allows us to put it in one of our standard forms, so we can relatively easily come up the graph. I say relatively easily. You see, it's not the greatest. And then once we get that graph, then just rotate it 45 degrees, and we'll have our real graph. Well, if you have a package like this, you can just plug it in directly. But again, that's what it allows us. So our final answer. And again, I'll just try to sketch this. We're taking this and we're rotating it 45 degrees. Use your imagination. Squint real hard and make things blurry, and then it'll look like it. We took this and we rotated it 45 degrees, and that would be our answer. So let me save that. I designed that one to come out nice. These other ones I don't think come out as nice. So what I'll probably do on the other ones, I'll just find all the different pieces, and I won't actually do the graph part. I'll go over that software and show it. And I was talking and wasn't focusing on what I was doing. I saved that, didn't I? Yeah, I did. You talk too much, you worry me to death. I like that song. Okay. Let's look at our next one. Number 5. And again, it says rotate the axis so that the new equation contains no xy term. Do the same thing we did before. Okay, so we got these first two I'm making pretty simple. I mean, you may look at that last one and think, well, that wasn't simple. The last one will be the hardest one. When I've created all these videos, I haven't had a script in front of me. And I don't have it in front of me now. But I do have it on the side. I went ahead and worked these problems, because these problems aren't trivial, and just so I want to make sure I get the right numbers and don't make a math error and throw an hour worth of work away. So I'm not following the script, but I'm looking over there to see if I'm getting the right answer at the end. Okay, yeah, let's go back up to our rotation formulas. Okay, first thing we need to do is figure out our angle of rotation. We need A, B, and C for that. Remember, A is what's before x squared. That's right here, which is 1. B is what's before xy, which is right here. And C's are what's before our y squared, which is 1. So we've got cotangent 2 theta is equal to A minus C over B, our formula right here. whenever A and C are the same, it makes it pretty simple. It's always a 45-degree rotation. We got A minus C, so 1 minus 1 over B, which is 16. Well, 1 minus 1 is 0. 0 divided by 16 is 0. So we ask, where is cotangent equal to 0? And the answer to that is cotangent is x over y. So it'd be when x is 0, which is at 90 degrees. So cotangent at 90 degrees is equal to 0. So what we do is we set 2 theta equal to whatever angle we come up with here. So we got 2 theta is equal to 90 degrees, or theta is equal to 45 degrees. So that's going to be our angle of rotation. Okay, let's figure out our substitution formulas now. Got these right here. Now, when this is a nice angle that's on a unicircle, then you just plug it in and you get it. If it's not on unicircle, that's where we use these bottom formulas, and we'll get to those. So we're going to have x is equal to x prime cosine theta minus y prime sine theta. And we got y is equal to x prime sine theta plus y prime cosine theta. Okay. Now let's plug in our 45 degrees. So we got x is equal to x prime cosine of 45 degrees minus y prime of sine of 45 degrees. And y is equal to x prime sine of 45 degrees plus y prime of cosine 45 degrees. Well, sine 45 degrees, cosine 45 degrees are both square root of 2 over 2 on our unicircle. So we're going to have x is equal to the square root of 2 over 2 x prime minus square root of 2 over 2 y prime. And y is equal to square root of 2 over 2 x prime plus square root of 2 over 2 y prime. Remember what I said, if you have common fractions, go ahead and factor them out. It'll make your life a lot easier. So I'll factor out square root of 2 over 2, and that gives us x prime minus y prime. And I'll factor out a square root of 2 over 2 here, and that gives us x prime plus y prime. You're better off not to deal with those x primes and y primes until the very end. So we're going to let p equal to x prime and q equal to y prime. So what we have is x is equal to square root of 2 over 2 p minus q, and y is equal to square root of 2 over 2 p plus q. And now we're ready to do our substitution. So step 3. Well, our original problem was x squared plus 16xy plus y squared minus 3 equal to 0. Okay. Then we said x is equal to square root of 2 over 2 times p minus q, so we'll plug that in for the x here. So we got square root of 2 over 2 p minus q, all of that squared, plus 16 times x times y. So we'll put the x in there. So we got square root of 2 over 2 p minus q times y, which is square root of 2 over 2 p plus q, plus y squared, and this is y, so we got square root of 2 over 2 p plus q squared minus 3 equal to 0. Now, since this is square root of 2 over 2 times p minus q, when we take the second power, we'll square this, and we'll square this. And the same thing over here. Square that, and square this. Well, square root of 2 over 2 squared. Square root of 2 times square root of 2 is 2. 2 times 2 is 4, so that becomes 2 fourths. And then we've got p minus q squared plus 16 times Square root of 2 over 2 times square root of 2 over 2. Square root of 2 times square root of 2 is 2. 2 times 2 is 4. And then p minus q times p plus q. And over here, again, when you square the square root of 2 gives you 2. And you square 2 gives you 4. And we got p plus q squared equal to, or minus 3. Almost made a mistake. These are a lot easier in class because I have eyes watching me and they usually point out my basic math errors. Okay. So this gives us 1/2 p minus q times p minus q. And what's that give us? 8? Yeah. 8. And multiply these together. These are conjugates. So all we have to do is multiply our first parts together and last parts. P times p is p squared minus q times q is q squared. P squared minus q squared. Now what conjugates is, the first and the second are the same, but the sign in the middle is different. See how this is p, p, q, q, but the minus and the plus. Okay. The 2/4 reduces to 1/2. And then we got p plus q times p plus q squared minus 3 equals 0. Okay, 1/2 times p times p is p squared. P times negative q is negative pq. Negative q times p is negative pq. Negative q times negative q is plus q squared. Plus, I'll multiply the 8 through. In case you're wondering, you don't have to show all the steps I'm showing. I always show more steps than just so if you need to see them. Why do I have that squared there? A lot of basic math. This is very simple math, actually, but it's just so much of it, it's easy to screw up somewhere. P times p is p squared. P times q is pq. Q times p is pq, and q times q is q squared. Minus 3 equals 0. Negative pq is negative 2pq plus q squared plus 8p squared minus 8q squared plus 1/2. Pq plus pq is 2pq plus q squared minus 3 equals 0. Okay, multiply the 1/2 through. So I got 1/2 p squared, 1/2 times the negative 2pq, the 2's cancel. So I got minus pq. 1/2 times q squared is 1/2 q squared plus 8p squared minus 8q squared. 1/2 times p squared is 1/2 p squared. 1/2 times 2pq, the 2's cancel, and we got a plus pq. 1/2 times q squared is 1/2 q squared. Minus 3 equals 0. Okay. Here's a negative pq and a positive pq. Those are going to cancel away. Here's a 1/2 p squared. Here's a 1/2 p squared, and here's an 8p squared. That gives me a 9p squared. Combine together like terms. Here's a 1/2 q squared, 1/2 q squared, and negative 8 q squared. Well, 1/2 plus 1/2 gives us 1q squared, minus 8 gives us negative 7q squared. Minus 3 equals 0. Let me double check my cheat sheet here. Yeah, I'm right on target. No math error. Okay, well, we got 9p squared minus 7q squared. Take negative 3 to the right side, becomes a positive 3. Now remember, we now let our p be x prime and q our y prime, our initial substitution. Well, not initial substitution, but when we got rid of those. So this becomes 9x prime squared minus 7y prime squared equals 3. And let me write this down, and then, actually I got it written down somewhere, do I? Oh. No, I guess I don't. I didn't show all the steps on my little piece of paper here. since I was doing it for myself. Okay, let me save this and we'll just go to our second page. I never know whether it works when it does that. It throws me in another page, drives me crazy. Did that work? Yeah, it did. Okay. What problem is this anyway? Number 5. Okay, so number 5 continued. We had 9 x prime squared minus 7 y prime squared equals 3. Obviously, this is a hyperbola. Let's put in a standard form of a hyperbola. Well, key thing is we need 1 on the right side, so we'll divide everything by 3. So I got 9x prime squared over 3 minus 7y prime squared over 3 equals 1. And that gives us x prime squared over, well, I was going to skip a few steps. Okay, let me put them in there. 9 and 3 both divisible by 3, so that gives us 3x prime squared over 1 minus 7y prime squared over 3 equals 1. Now, when you got a number up there with your x and y, you can, you see how this is 3 over 1? I can put the reciprocal of it down in the denominator, so this would become 1/3 minus y prime squared, and this would become 3/7. Because if you think of it going the other direction, if you flip this and multiply it times your top, you would have this. Equals 1. Well, we're trying to get this in standard form, so we still have a little bit more work to do here. I'll write this as x prime minus 0 squared. I want this as something squared, and we'll put square root around it, like that. Minus y prime minus 0 squared. And this would be square root of 3/7 squared equals 1. Okay, well, let's actually I need to simplify that a little bit. So this becomes x prime minus 0 squared over, and this becomes, well, let me show all the steps. Can't have a fraction inside of a square root, so split it up. Square root around the top, square root around the bottom. Same thing over here. The idea of these videos is you don't have any questions after you get done with it. That's why I try to show all the steps. Same thing here. You can't have a fraction inside of a radical, so we split it up, square root on top, square root around the bottom. Well, we can't have a square root in the denominator. So on this one here, we'll multiply top and bottom by the square root of 3. So this becomes square root of 3 over 3 squared. And this one here, multiply top and bottom by square root of 7. So that gives us square root of 21 over 7 squared equals 1. Well, now we're ready to identify our variables. Now here we got a minus, and the squared of the x squared is before the minus. So x squared before the minus. Over here the y squared is before the minus. So we're dealing with one on the left again. So left. Now this number here from our left formula is going to be our h. It's opposite sign, but 0 doesn't have a sign. And this would be our k. Opposite sign, but again 0 doesn't have a sign. Our a is underneath the x squared, so this is a. A is square root of 3 over 3, and this is our b. So b is square root of 21 over 7. Well, we need c, and then we can find all our different pieces. And I'm not going to try to graph this. You can see that things aren't coming out nice. So I use this formula. We got b squared is equal to c squared minus a squared. Well, b, and you know, To be honest, this is probably not the best form to pick. Probably the original B, before I started changing it would be best, but I'll choose this. So square root of 21 over 7 squared, C we don't know, minus A, which is square root of 3 over 3 squared. Well, square that gives me 21 over 49 equals C squared minus, and that gives us 3 over 9. So I got 21 over 49 plus 3 over 9 is equal to C squared. Actually, that reduces to 1/3, doesn't it? I was just double checking myself here. Okay. Both those reduce. Would have been better to go up there. These are both divisible by 7. Watch me make a basic math error here. And that's 1/3. 3/7 and 1/3. Okay, that looks much better. Get a common denominator. I don't have this part worked out in my piece of paper, so I'm a little bit worried about basic math error. Okay, multiply bottom part by 3, top part by 3, so that gives me 9/21. Top and bottom by 7. So that gives us 16 over 21 is equal to C squared. C is equal to square root of 16 over 21, which is square root of 16 over square root of 21, which gives us 4 over square root of 21, which gives us 4 square root of 21 over 21, assuming no basic math error. Let me write down all these pieces of information now. Let's see, H is 0, K is 0, A is square root of 3 over 3, B is square root of 21 over 7, and C is 4 square root of 21 over 21. Assuming I didn't screw up somewhere. And let me save this. This is 5 continued. The never-ending problems. There it is. A is square root of 3. Boy, my writing's bad. I can't read it. 3. B is square root of 21 over 7. And C is 4 square root of 21 over 21. H is 0. K is 0. Okay. And formula on the left. Okay. So let's look at our formula on the left. We got center, which is HK. So that'd be 0, 0. Let me try to graph this one. I think this one comes out decent, maybe. Famous last words. Parallel to the x-axis. Parallel to the x-axis. Here's the x-axis, so it'd be this way. So it'd be the form y equals. So our transverse would be y is equal to 0, which means our graph would look something like that. Okay, so foci, even though we're not going to use those, let me go ahead and find them. H plus ck and h minus ck. H is 0, C was 4 square root of 21 over 21, K is 0. And this would be 0 minus 4 square root of 21 over 21, 0. So we got 4 square root of 21 over 21, 0. And negative 4 square root of 21 over 21, 0. Okay, our vertices would be h plus a, k, and h minus a, k. Well, h is 0, so we've got 0 plus a, which is square root of 3 over 3, k is 0, and this would be 0 minus square root of 3 over 3, 0. So we got square root of 3 over 3, 0, negative square root of 3 over 3, 0. And that's about useless. So let me see what that's equal to. Square root of 3 divided by 3, 0.58. 0.6. So 0.60 and negative 0.60. I'll come back to that. Let's look at the asymptotes. Asymptotes is y minus k is equal to plus or minus b over a, x minus h. K is 0. Plus or minus b was square root of 21 over 7 all over a, which is square root of 3 over 3, and x minus 0. So I'll have y is equal to plus or minus, and I'll flip the denominator, or flip the fraction and multiply times the top. So I've got square root of 21 over 7 times 3 over square root of 3, x, which gives us 3 square root of 7 over 7, x, plus or minus. Since these are both in square roots, 21 divided by 3 gives you 7. Simplified a little bit there. Well, that doesn't help us a whole lot. Let's put that into decimal form. 3 square root of 7. Let's see what in the world that is. 3 square root of 7. 7.9? 7.9. Boy, that's so close. I'm just going to say 8. So 8 over 7, x. That's an approximate, of course. That's our asymptote. Now vertices. 0.6. Well, 0.6, that'd be about right here. That's our vertex. And negative 0.6 would be about right here. Now this is almost the same. So that's almost, it's actually going to go up 8 and right 7. So it's not quite at a 45 degree. It's a little bit less. Let me just guesstimate this. A little bit less. And same over here. Okay. And this is a real rough sketch. Get that. And we get this. And this is going to be rotated 45 degrees. Well, let's look at our original problem. Actually, let me double check myself here. Okay. Actually, I already double checked it. Never mind. Rotate that 45 degrees. That's almost going to look like the other one, won't it? Let me come over here. I'm going to cheat. Okay. Then what we came up with was 9 x squared. So x. I wonder if I do xx. minus 7y squared, yy, equals 3. Okay, that well, that should look like my sketch there. That's about as good as I'm going to get doing that. And then our true graph is going to have be that rotated 45 degrees. Well, this one actually allowed me to put the original one in. And let's see if it looks like it's correct. So if I do implicit, our original problem was x squared plus 16xy plus y squared minus 3 equals 0. Does that look like the red has been rotated 45 degrees? It does, doesn't it? And I could actually, hopefully, I never have done this, but let me try to rotate that one. So let me do 1, rotate, and angle, pi over 4. Look at that. It fell right on top of the blue one, didn't it? So that checks it. But again, what we're doing is taking this and we're rotating it 45 degrees to get our final answer. Now I realize this is not our answer. Our answer is that rotated 45 degrees. And again, I'm not very good at rotating these. Better if I have a piece of paper, I just rotated 45 degrees. Okay, that's probably as good as I'm going to get. But you get the idea. So let me save that. And let's look at the hardest one. Quit choosing ones that are just easy. I'm not even going to try to graph this one, but I may try to find different pieces. Okay. Let me see. I worked this on a separate piece of paper, and it looks like I had like 3.5 pages. So it's a long problem. Let's take a look at it. We got 9x squared minus 6xy plus y squared minus 10 square root of 10x minus 30 square root of 10y equals 0. Let me double check everything. Okay. Well, let's figure out our angle of rotation. So need A, B, and C. Well, A is 9, numbered for x squared. B is numbered for xy, which is negative 6. And C is our number for our y squared, which is 1. And we got cotangent 2 theta is equal to A minus C over B. So we've got cotangent 2 theta is equal to A, which is 9, minus C, which is 1, over B, which is negative 6. So we've got cotangent 2 theta is equal to 8 over negative 6. Cotangent 2 theta is equal to negative 4/3. Now, cotangent is equal to negative 4 over 3. Well, let's think where that's at. Cotangent is x over y. So this would be negative 4 as our x and y as our 3, which would fall in here somewhere, wouldn't it? It could also, if I put the negative down below, it could also fall down here. We don't want a negative rotational angle though, so let's work with this one right here. Because if we go further with this, our cotangent 2 theta is equal to negative 4 over 3. I can rewrite cotangent as 1 over tangent 2 theta is equal to negative 4 over 3. I can flip both of these. If you have a single fraction on both sides, you can flip them. So it becomes tangent 2 theta over 1 is equal to 3 over negative 4. So then 2 theta is going to equal to, this is obviously not on our unicircle, so there's no use to even look. Our 2 theta is equal to inverse tangent, or arctangent, if you learned it that way, of negative 3/4. Now you want to make sure your calculator's in degrees, and I don't have my calculator, so let me bring it up. Grab a drink while I'm at it. I'm dying here. So I'll press mode. I'm in degrees, so that's fine. Do a second mode exit out. And I'm going to do my second tangent to get the inverse tangent. And negative 3/4. So we got negative 36.87 degrees. Remember me saying we don't want negative angles. Inverse tangent only gives you these two quadrants. So it gave us over here, gave us negative 36 somewhere over here. We want over to here, because we want the smallest rotational angle. Well, what we do to this is we add 180, and that'll take us over there. Remember the tangent and cotangent, you can add 180 or add pi. So I'm going to do a plus 180, and that gives us 143.13 degrees. And then I want to solve for theta, so I divide both sides by 2. And I'll just round no decimal places, 72 degrees. You know, if you were actually trying to eyeball this, you're not going to be able to see. I mean, you'll be lucky if you see 72 degrees. 70 might be good enough. But this isn't good. This isn't on our unicircle. So we can't get the nice substitution formulas like we did before. So we got to do it a different way. This is where we use the bottom formulas to help us get cosine and sine. So, since not on the unicircle, we said cotangent of our double angle is equal to negative 4/3. Which is in this, we said was in this quadrant right here. Now theta is over here. Theta is 72 degrees, so theta's over here, but 2 theta is over here. Well, then this will be, remember cotangent is x over y, so this is x, and this is y. So we're going to use our x, y, and r formulas. So we're going to find r. Remember, r squared is equal to x squared plus y squared. R is equal to square root of x squared plus y squared. So r is equal to negative 4 squared plus 3 squared. So r is equal to square root of 16 plus 9, which gives us square root of 25, which gives us 5. Now for these formulas, we're going to need cosine of 2 theta. Now cosine of 2 theta is going to equal to x over r. Now you're sitting there saying, well, we didn't have 2 theta before. Well, it doesn't matter. The fact that this was 2 theta here means I can have 2 theta here. So cosine of 2 theta is going to equal to x was negative 4 and r is 5. So now we're going to use these two right here. First, let's look at the cosine. Cosine theta is equal to the square root of 1 plus cosine 2 theta over 2. So this would be 1 plus negative 4/5, so 1 minus 4/5 over 2. I could multiply everything by 5, so I multiply the 1 by 5, and that gives me 5, minus, I multiply the 4/5 by 5, and that just gives me 4, and I multiply the 2 by 5, and that gives me 10. So we've got cosine theta is equal to square root of 1 over 10, which is square root of 1 over square root of 10, which gives us square root of 10 over 10. Now this is a precise value. So when we plug that into our substitution here, it's going to be precise, which is what we want. And then second thing. Sine theta from our formula is equal to this. So square root of 1 minus cosine 2 theta over 2. And 1 minus cosine 2 theta we said was negative 4/5. So that's going to be a negative 4/5 there over 2. Negative negative becomes positive, so we got 1 plus 4/5 over 2. Multiply everything by 5, so that gives us 5 plus 4 over 10, which gives us 9 over 10, which gives us square root of 9 over square root of 10. I'm about out of room. Which gives us 3 over square root of 10, which gives us 3 square root of 10 over 10. And let me circle on my sheet if I can find out where I'm at. There we go. And let me save that page. So glad I drank a lot of pop before I started a long video. Okay, so whatever problem this is, we're continuing it. It's 6, I guess. So 6 continued. And what we just found is we found that cosine theta is equal to square root of 10 over 10, and sine theta is equal to 3 square root of 10 over 10. So now we're ready for our substitution formulas. So we've got x is equal to x prime cosine theta minus y prime sine theta, and y is equal to x prime sine theta plus y prime cosine theta. Okay, so we got x is equal to, and we just said cosine theta is equal to square root of 10 over 10, so we got square root of 10 over 10 x prime minus sine is 3 square root of 10 over 10 y prime, and this one sine was 3 square root of 10 over 10 x prime plus cosine is square root of 10 over 10 and then y prime. Well, let's factor out what they have in common. Well, they both these have square root of 10 over 10, so I can factor that out. And that leaves us x prime minus 3 y prime. And on this one, we'll factor out a square root of 10 over 10. And that gives us 3x prime plus y prime. We're going to let x prime be equal to p and y prime be equal to q. So we've got x is equal to the square root of 10 over 10, p minus 3q, and y is going to equal square root of 10 over 10, and then 3p plus q. Let me double check myself here. Where am I at? Okay, good down to that point. Well, now we're ready to substitute that in. So our original problem was this. So we got 9x squared minus 6xy plus y squared minus 10 square root of 10 x minus 30 square root of 10 y equals 0. Okay, so x we just said was this. So we got 9 times square root of 10 over 10 p minus 3q squared minus 6 times xy. X is square root of 10 over 10 p minus 3q. Y is square root of 10 over 10 times 3p plus q. It's a 10 down there. Plus y squared. So we have square root of 10 over 10 3p plus q squared minus 10 square root of 10 times x, and x is square root of 10 over 10 p minus 3q minus 30 square root of 10 times y, which was square root of 10 over 10 3p plus q equals 0. So again, I just went through it, and everywhere I had an x, I plugged in this, and everywhere I had a y, I plugged in this. Let me double check myself. Actually, I got a piece of paper here. I think, well, double check myself here. That looks right. Again, if we have a squared, we can square this separate from this. And same thing here. Square that separate from that. So I have 9 times, I square this. When I square a square root of 10, it gives me 10. And 10 squared is 100. And I've got p minus 3q squared minus 6. Square root of 10 over 10 times square root of 10 over 10. Square root of 10 times square root of 10 is 10. And the denominator is 10 times 10 is 100. And we've got p minus 3q times 3p plus q. And here, square this. That gives me 10. And square the 10, and that gives me 100. And then we got 3p plus q squared. Now here, square root of 10 times square root of 10 is 10. Divide by 10, that drops away. So we're left with negative 10.
Avast virus database has been updated.
I hate you, Avast. Just threw away my mind concentration. Hate when it does that. Okay. Negative 10. So we got minus 10 times p minus 3q. That's this part right here. Okay, here, square root of 10 times square root of 10 is 10, divided by 10 is 1, so it drops away. So we've got minus 30 times 3p plus q equal to 0. Okay, well, this is 1/10, so that gives me 9/10. So I got 9/10 times p minus 3q squared minus, this is 1/10, times 6 gives me 6/10 times p minus 3q, and then 3p plus q. That gives me 1/10. So I got 1/10 3p plus q squared minus 10 times p minus 3q minus 30 times 3p plus q. Now let me find this on my sheet and double check my math. 9/10 minus 6/10. I kind of did this different on my sheet, but I think I can tell what I'm doing. Okay, Now, one thing I did do on my sheet, and I'm going to do it here, is I don't want to work with fractions. These are hard enough as is. Well, I'm going to multiply everything by 10. So I multiply this by 10, and this becomes 9 times p minus 3q squared minus 6 times p minus 3q times 3p plus q. When you're multiplying this entire thing by 10, you can just multiply the number out in front by 10. Same here. And this becomes 3p plus q squared. Multiply this 10 by 10, I get minus 100 times p minus 3q minus 30 divided by 30 times 10 is 300. 3p plus q. Okay, well, this gives us p minus 3q times p minus 3q minus 6. I'm going to go ahead and multiply these together. P times 3p gives me 3p squared. P times q is pq. Negative 3q times 3p is negative 9pq. Negative 3q times q is negative 3q squared. Plus 3p plus q times 3p plus q minus 100p, negative 100 times p, negative 100 times negative 3q gives me plus 300q, negative 300 times 3p is negative 900p minus 300q equals 0. And let me do some checking here. 300q minus 900p minus 300q minus 100p. Okay. Wish I had done it the same as my sheet. Make it easier. P times p is p squared. P times negative 3q is negative 3pq. Negative 3q times p is negative 3pq. Negative 3q times negative 3q is plus 9q squared. Minus 6, combined against like terms. pq minus 9pq is negative 8pq. Minus 3q squared. Plus 3p times 3p is 9p squared. 3p times q is 3pq. Q times 3p is 3pq. Q times q is q squared. Now negative 100p and negative 900p, I'll combine this term with this term, and we get negative 1000p. 300q minus 300q drops away, so equals 0. Okay, so we got 9 times p squared minus 6pq plus 9q squared. Multiply negative 6 through, and I got negative 18p squared plus 48pq plus 18q squared plus 9p squared. 3pq plus 3pq is 6pq plus q squared minus 1000p equals 0. 6pq 3. Huh. Guess I can't look at my sheet too close. I made a math error on it. I have 3p squared here, but that definitely should be 9p squared. I don't know where I multiplied it together, but 3p times 3p is 9p squared. These are so easy to make a basic math error. That's why I was trying to go off of a script, but obviously not successfully. Okay, 9 times p squared is 9p squared minus 54pq plus 81q squared. Now, here we have a mess. Negative 18p squared and 9p squared. That gives us negative 9p squared. Um, Here we have 48 PQ and 6 PQ. That gives us 54 PQ. Here's 18Q squared plus Q squared. 19Q squared minus 1000P equals 0. Okay. Let me see what in the world this problem really is to begin with. Remember our b squared minus... okay. Let me identify A, B, and C. Okay, we said A is 9, B is negative 6, and C is 1. I was real confident because I had my script in front of me, and my script's wrong. So I got b squared, which would give me 36, minus 4 times A, which is 9, times C, which is 1. It gives me 36 minus 36, which is 0, which is indeed a parabola. Oh, too cool. Stupid script. That's what I'm getting. It's going to be a parabola. Okay, so that right there, which makes sense why it didn't look like a hyperbola when I graphed it. I just assumed it was so far off. 9p squared minus 9p squared drops away. Negative 54 PQ and positive 54 PQ cancels. So I got 81 Q squared plus 19Q squared. I guess I can combine those together, can't I? Of course, now I'm unnerved. 81 plus 19, 90, 100 Q squared. And what else is left? Minus 1000P is equal to 0. So I'm going to 100P squared, take the 1000 over here, 1000P over there. Let me write that down. I'll continue on the next page. Well, I was wrong. This one's going to work out pretty nice if that's the case. I have no problem. 6. I was trying to. I have no idea which problem I'm on. Okay. And what did I get? Q squared is equal to 1000P. Mm. 100 Q squared is equal to 1000P. Okay, yeah. Well, obviously I can divide both sides by 100. So I get Q squared is equal to 10P. Now remember what we had these equal to. P was equal to X prime, and Q was equal to Y prime. So this would becomes Y prime squared is equal to 10 X prime. Okay, standard form of a parabola. Oh. Getting close to getting done. That's good because my bladder's about to float away. Square root is on the y. We want the bottom formula. Well, we want to rewrite that as y minus something, and you can always put a 0 in there if you have no other number. Now we need a parentheses before the x, so you can always create a parentheses before the x by factoring out the number that's there. we want to rewrite this as 4 times something, and the x prime becomes x prime minus 0, because again, we need it as x minus something. Well, if you can't think how to rewrite 10 as 4 times something, just put whatever numbers here, put up in the top, and then denominator you put a 4. Because if I were to go backwards, those 4s would cancel and give me the 10. So then, k would be here, and its opposite sign, but 0 again doesn't have a sign. This would be h, and its opposite sign, 0. And this would be our p, and it stays whatever sign it was. Now that reduces. 10/4 is 5/2. So then our vertex is hk, which is 0, 0. And our focus is h plus pk. Well, h is 0 plus p, which is 5/2 and 0, which would give us 5/2, 0. And our directrix is x equals h minus p. H is 0 minus p, which is 5/2. So we got x is equal to negative 5/2. Okay, vertex is 0, 0, which is right here. Focus is 5/2, 0. 5/2 is 2.5. So this is our vertex, this is our focus. And directrix is negative 5/2, negative 2.5. It should be right here. Now remember, we to graph this, we pick a point, and you're looking for one equal distance from the directrix of focus. That's probably not bad there. Probably not great, but let's see. I'm not very good at eyeballing these. Maybe right there. Again, what I'm doing is eyeballing the distance from this point to the focus is the same as the distance to the directrix, forming a 90-degree angle. And same here. This distance here should be the same as this distance here, forming a 90-degree. Now once you get a couple points, you know what a parabola looks like. It's going to be something like that. And then by symmetry, this will be something like that. Now we're going to take that and we're going to rotate it 72 degrees. Well, I'm going to cheat and plug in our original problem. Actually, let me start a new one. What did we come up with here anyway? Y squared is equal to 10x. Boy, that came out nice, didn't it? All that work. So equation implicit, y squared equals 10x. Well, that right there should look like what I sketched, which, use your imagination. It's probably not too bad. And I want to rotate that 70 degrees. So if I come up here, 1, rotate. Not 70 degrees, 72 degrees I mean. Angle. And that'd be 72 pi divided by 180 if I were to switch that to radians. And click rotate. And that would be our rotated graph, which would be our answer. So this right here is our answer. Now let's compare that against the original to see if I'm correct. So if I come up here, you do equation, implicit, wherever the implicit is, there it is. And I'm going to do 9x squared, this is our original problem, minus 6xy, plus y squared, minus 10 square root of 10x. I know you probably can't see that real well. Minus 30 square root of 10y, I know I can't, equals 0. And graph, and see how I fell right on top of that? This actually looks a little bit off, doesn't it? I'll blame that on this wind plot program, because my math is perfect, I'm sure. But anyway, that gives us our graph. Again, you come up with this, and if I weren't using that that cheating program, I would rotate this 72 degrees. and we'd get this. And again, I'm not very good at rotating it, so let me cheat and look at this. A little bit of roughness there, but use your imagination. Squint real hard. It'll appear blurry and it'll look good. But that's our answer. Actually, it came out really nice. Feel bad I screwed up on my script on it, though. You can see how easy it is to make a basic error on these. These aren't hard problems. Very tedious. A lot of basic math. I mean, this is algebra you saw back in elementary algebra. So we're not talking like some real advanced stuff here. But there's a lot of it. So let me stop the recorders now. See how long I've been going. Hour and a half. Not too bad.